Year 12, and welcome to Purple Mountain Maths. We are doing the 2025 HSC paper for Mathematics Advanced. This is part 3, covering question 14 and 15, worth 12 marks. Question 14. In a research study, participants were asked to record the number of minutes they spent watching television and the number of minutes they spent exercising each day over a period of 3 months. The averages for each participant were recorded and graphed. We're given a graph where the y-axis shows average minutes per day exercising and the x-axis shows average minutes per day watching television. Part A says describe the bivariate dataset in terms of its form and direction. Pause here to try yourself. Right, I can see that this is linear. It's certainly not non-linear. The answer to form is linear. And that it is sloping down. It has a negative slope. The direction is negative. We're told that the equation of least squared regression line for this data set is y equals 64.3 minus 0.7x. Part B says interpret the values of the slope and y-intercept of the regression line in the context of this data set. Pause here to try yourself. Okay, recall which one was x and which one was y. Y was minutes exercise and x was minutes of TV watching. So a slope of minus 0.7, which represents the rate of change of exercising compared to TV watching, i.e. as TV minutes increase by 1, the number of minutes of exercise drops by 0.7 of a minute, which is 42 seconds. The y-intercept of 64.3 tells us how many minutes of exercise would be expected if there was no TV. If no TV watching, 64.3 minutes of exercise is expected. Part C. Joe spends an average of 42 minutes per day watching television. Use the equation of the regression line to determine how many minutes on average she's expected to exercise each day. Pause here to try yourself. So they're telling us that x equals 42, and we're going to substitute that into the formula. Y equals 64.3 minus 0.7 times 42, and we get an answer of 34.9 minutes. Part D. Explain why it is not appropriate to extrapolate the regression line to predict the average number of minutes of exercise per day for someone who watches an average of 2 hours of television per day. Okay, so clearly they're asking us to comment on the fact that extrapolation is unreliable. The data is only provided for X values, i.e. TV watching values, of 0 to 60 minutes of TV per day. 120 minutes of TV watching is far outside the data set. So using the equation of the line would be unreliable. If you do substitute in, if x equals 120, then y would equal minus 0.7 times 120 plus 64.3, which would result in a negative value, which is meaningless. Question 15. A sound wave can be modelled using a function P of t equals k sine AT, where P is air pressure in pascals, T is time in milliseconds, ms, and K and A are constants. Part A. Write the equation for a sound wave P1 of t that has amplitude of 2 pascals and a period of 5 milliseconds. Pause here to try yourself. Okay, so we know that the period, which is often represented by Greek letter tau, equals 2 pi on A. We know that the period is 5, so 5 equals 2 pi on A, or A equals 2 pi on 5. We also know that the amplitude equals K equals 2. So my equation P of t equals 2 sine of 2 pi on 5 t. Question 15 continued, Part B. The graph of P1 of t from Part A is shown. On the diagram, sketch the graph of P2 of t, which is 4 sine pi t on 10. Pause here to try yourself. First of all, we can see that the amplitude is going to be 4. Period equals tau equals 2 pi on A, which in this case 2 pi on 10. So I get 20. I'm only being invited to sketch it for t up to 10, so I can see that only half of my sine wave is going to fit in the first 10 milliseconds. So the halfway point is here, 5,4. I know when I'm 1/3 of the way through that piece, I'll be at 2. I need to go up and down. Part C. Hence, find the values of t where t is trapped between 0 and 10, for which the functions P1 of t and P2 of t are both decreasing. We worked out above that P2 of t is decreasing for t above 5. And we need to consider where P1 of t is also decreasing. We know that P1 of t has a period of 5. So each quadrant is 5 on 4. P1 of t is decreasing in the second and third quadrant, i.e. 5 plus 5 on 4 until 10 minus 5 on 4, which is 8 3/4. So we can conclude both curves are decreasing when t is trapped between 6 1/4 and 8 3/4. That's the end of part 3. Thanks for listening to Purple Mountain Maths.